slow. Very gently. Okay, let's test it. Okay, very slowly, come to a stop. Very slowly. Here's what the hazelnut planting looks like. So we've got the plants put in. They come out of these tubes. Here's a truck with a water barrel. Here's the plants as they look. They've been decapitated and starting to grow. Then Alec is out there covering them with some hay. Steps are to poke a hole with a bulb planter. Put the plant in, holding it tightly. Put the soil around it so it's nice and tight. Then go down a road far and far. So you've got many of these lines down the key lines, basically down the contours. The idea is use weather like right now. It's towards evening. The instructions from Phil Rutter from Badgersett are do it after 3 p.m. So this is July, and it's a perfect time to plant. I mean, these plants have been seeded early this spring. Now they're ready to be planted, so they're planted the same year. That's an overview of the planting process. About 5,000 to go. So we're going to plant out about 30 acres or so. We're here learning how to use a level to mark out contour lines. We're planting out 5,000 plus nuts here. Alec, tell us how you line out the contours.
Okay, so the first step is to take the machine and get it in place. It has to be near where the level you want, but it doesn't have to be on it. You're going to calibrate the level with this stick. So this could be over there or down there, it doesn't matter, as long as you've got line of sight with it. It has to be close to upright to get going, but once it's pretty much close to upright, it will self-level and start sending out the laser that tells you where the level is. So once that's in place and going, which it is now, next step is to calibrate the stick with the receiver on it. So we turn this on here, and we put the base of this stick on the peg that marks the level that we want to stay on.
Yep.
So this is going to be there, and now we let it tell us be on the level that you're going to follow. You'll set this so that it'll beep to tell you that you're level with the laser there.
Yep.
So now anywhere you put this stick down, it'll be level.
Yep.
With this stake here.
And use that little bubble to make sure you're vertical.
Yep.
And this will beep to get you. It knows that it's on the same level. So then we move it over.
The next step will be to walk to wherever you want to put the next stake. Maybe it'll be 50 meters or whatever you're doing. Put it in the ground, and when it starts to receive the laser, it'll start to beep and tell you whether you're too high or too low with these little arrows on here.
Right.
So you'll walk to where you think it's right and go like this until it starts to beep, and then stick it in the ground and go up a little bit if it needs to go up, or down a little bit. Once you find it, there you go. That's your level.
That's your level right there, and put the stake right at that point.
Yeah, exactly.
And continue doing that. And just walking over the challenges on this. If you got gullies, what's the issue there?
Yeah, so just when you're laying out the stakes, make sure that you're actually following the land shape. If you have a gully that you're crossing, you could be putting stakes every 50 meters or something, and you could completely miss that curve in the land. And when you come to plow it, you either have to eyeball it, or you'll go straight over it and end up with a dip, which you don't want. So just be aware of the land shape. You can have quite long distances between stakes if you want, when the land is consistent, but as soon as you start to get a form that's a bit more varied, you have to be on top of it and put the stakes closer together.
So pretty transparent. You can see some of the stakes lining out the contours. We're planting the nuts right on the contours. And now we're getting into QGIS using a simple camera app. The camera app is called what?
Using GPS Tour, and it's just a little thing on your phone that tells you where you are, so I can stand over any stake and record the location and export it as a KML file, which we can import into QGIS. And
so I have an overlay of points on the QGIS map. Care of our QGIS open source mapping workshop.
Yep.
Okay. Thanks, Alec.
Yep.
Here's what a planting operation looks like. Water tank. Here are the recent plantings. The flail mower back there leaves behind a bunch of broken down grass, which is then used to cover the plants after they're planted straight from the tubelings. You can see the keyline rip. That's where we're planting into using a bulb planter. So this is how it looks, and here is the area where it's not been planted yet, but the rip is here and the finely pulverized soil is here. Now going to the machine. Machine review. The flail mower works like this. You got the keyline shank here. Look at the flails. That's how they look. I saw last night actually that they spark when they hit the ground from time to time. This is a whole open source machine using donut tires, box beam tubing, the standard modular hydraulic motors, chain coupler, simple cover made of plywood from the top, quick connect hydraulics everywhere. Using box beam tubing, the full CAD file is here. Here's the mess of hoses. Here's the machine itself. What's the review like on here? Traction is excellent. Actually, we got the van stuck the other day in the mud. This device with the flail mower pulled the truck right out as if it weren't even there. The traction is pretty significant here. We got the 1/4x2 angle. One feature here is that this drive sprocket here, which you see, that's quick connect using these bolts. It's not a keyway, it's just clamped on bolts. Here's the idler, here's the tracks. We did have a track come apart, so we had to so far replace the tracks twice. One time the pin fell out and the track broke. Other than that, we had a couple of these track pieces break off. That's a broken piece right here, but otherwise it's looking good. There's a bunch of stuff that gets wrapped around here. Chain coupler to the universal rotor. That's what the universal rotor looks like. Once again, simple box beam tubing. You got your hydraulic valves. Everything is quick connect, so we can reconfigure whichever power cube we want to. Here's an example of the design for this assembly here. That's take out a bolt, and you can pretty much take apart the power cube. I had to actually reach into some of the throttle here to make the engine go right. But that's it. You can see the hydraulic pump, which is the device that puts out the high pressure hydraulic fluid flow that drives the entire machine. Here's the hydraulic fluid tank with a temperature and level gauge. That's the fuel tank. There's some weight on the front here, maybe like 500 pounds to counterbalance it a little more. Here you see another track piece broke. We had a couple, 2 or 3 of them break. They're not, they weren't welded well, so I just kind of welded that back up there. Yeah, and this traction here, it's really good. I mean, it's solid, it pulls. And here you can see, so this idler here, if you can see, that's also a clamp on. This is not using a keyway, but just simple quick connect clamps using like 3 bolts on each side, so 6 bolts attach this high torque device, which this is holding 3,000 pounds of pulling torque on each side, so it's about 6,000 pounds total. But that's a quick overview of the machine. Everything here, quick connect. You can wire up this circuit in series or parallel. And right now the two power cubes are running independently. One is powering the flail mower and the other one is powering the tracks. That's a quick overview. Altogether, very pleased with the system so far. Excellent traction, and just going along here, planting out all the different lines. Yeah, so if you look at this whole situation here, we see some plug up. Every so often this has to be cut off. This has to be removed here. It gets kind of plugged up. Keeps bunching up. So maybe do some kind of a cutter wheel. But as you see here, it pretty much strips the ground. Works relatively well. Quite pleased with it.